This video is about Module 3, Lessons 8 and 12. And in this lesson, we'll talk about how to find the volumes of prisms, pyramids, cylinders, cones, and spheres when given the formula. And we're also talking about how to find the density of solids when given dimensions and the mass. Let's get started. We've used this Park reference sheet in the past, and luckily a lot of it has to do with geometry. We're focusing on these 5 equations, which will be given to you, or I guess you can use. So, first of all, a prism is where you have some kind of a shape. I'll draw a triangular prism. There's a triangle, okay, on top, and it's the same all the way through. And the bottom is the exact same. I should have drawn this dotted lines. Anyway, but that's a terrible picture. But the bottom and the top should look the same. Anyway, so it's the same all the way through, and that's a prism. Okay, you find the volume of a prism by finding capital B is the area of the base. Okay, one thing to know about these formulas is that capital letters are areas or volumes, lowercase letters are lengths. Okay, so this h is lowercase, height is a distance or a length, capital B is the area of the base. The most common mistake that I find is that for prisms, students take some length they think is the base and they do base times height, like a rectangle or a parallelogram, but in 3D general prisms, it's the area of the base times the height. Okay, before I move on, I want to do one of those. Okay, this is a much better picture of a prism. Notice you have a triangle on top. Okay, you have the exact same shape on the bottom. Okay, and you have rectangles on the sides, but it's kind of, if you look at cross sections, they're all the exact same triangle. Okay, so this is a prism. It's a triangular prism. Okay, so the volume is the area of the base times the height. So I got to figure out the area of the bases. Okay, to keep this simple, I like to go somewhere else and define the area of the base. Okay, so I'll go over here. The area of the base. Now I got to think about what the base is. The base is a triangle. Okay, and the way you find the area of a triangle is 1/2 the base of the triangle times the height of the triangle. Now there's some confusion here. Okay, so this capital B is the area of the base. This is the height of the prism. So maybe the h sub p is the height of the prism. Okay, this is the height of the triangle and the base of the triangle. So I know there's bases and heights. I get why it's confusing. Okay, let's keep going. This is the area of the base. We can kind of just color code it so it's easier for us. Let's make this be the area of the base. So I'll kind of keep things in this color. Okay. All right. Now, the way that I find the area of this triangle is 1/2 the base of the triangle times the height of the triangle. Now, I notice some things here. First of all, I notice that I know this length right here. That length is 1.5, okay, which looks like a height. And perpendicular to that is this length right here, which is the same as this length right here. So this is the base. This is also 5 yards. So the base of my triangle is 5 yards. And the height of my triangle is 1.5 yards. Let me just compute just the area of the base. The area of the base is 3.75 square yards. Okay, I can put that in right here. 3.75 is the area of the base times the height. Now, another common misconception is this height is not the height of the triangle. This is the height of the prism. That's this height right here and this height right here, and it's 4 yards. Okay. Now if I multiply the area of the base, 3.75 times the height of the prism, 4, I get 15 cubic yards. 15 cubic yards. And that's the volume of this triangular prism. Okay, area of the base times the height. Now let's go back here. I won't give an example for all of these, but I do want to talk through some of these equations. Okay, a cylinder is a circle. It's actually a kind of prism. It's a cylinder on top, a circle on top, circle on bottom, and kind of circles at every cross section, every horizontal cross section. Okay, now it's pi times the radius squared times height. Okay, which actually is the area of a circle, pi r squared, times the height. That's how I think of it. Okay, spheres, as you may know, are like balls, or like the Earth is a sphere. Okay, and that is 4/3 pi r cubed. Okay, 4/3 pi r cubed. There's ways to derive that. I don't have time for it in this video. Okay, a cone is 1/3 pi r squared height. Again, notice it's the same as a cylinder. Same as a cylinder, pi r squared height, but it's 1/3 of that. Okay, I wish I had more time to talk about why that is, but it's 1/3 pi r squared height. Okay, the last one is a pyramid. Just like a prism, it can be a rectangular pyramid or a square pyramid or a triangular pyramid, but whatever it is, if it's a square pyramid, for example, then it's the area of the base, whatever the base is, times the height, 1/3. It's very much like, the 1/3 idea from a cone, linked with the idea of the volume of a general prism. Okay, I do want to do one example of a pyramid. Let's do this one. This is also a triangular pyramid. Okay, remember that the volume of a pyramid is 1/3 area of the base, capital B is area of the base, times the height. Okay, now again, I mentioned I like to go off to the side and find the area of the base separately, so it keeps this a little simpler. Okay, the area of the base, now the base is what shape? The base is, I'll just keep it consistent, I'll color this orange again. The area of the base is a triangle. Okay, and the area of a triangle is 1/2 the base of the triangle times the height of the triangle. So I know there's bases and heights, lots of those going on. Keep them straight. Okay, just the triangle. Okay, now this, I'm not sure if you see this, but right here there's a right angle. Okay, which means this length right here, this 3, is perpendicular to this length right here, that's 4. Okay, so I can use, let's say, 3. Is that miles? Holy cow, what is this? 3 miles, and the height is 4 miles. Okay, so I get half of 12 square miles, or 6 square miles. That's the area of the base. Okay, I can plug that in right here. Whoop. Right here, 6 miles squared times the height. Now, this is not the height of the base triangle. This is the height of the pyramid, which is right here at 5 miles. I'm curious to know what this is. It's huge. Okay, 5 miles. Okay, so I multiply 1/3 times 6 times 5, I get 10. This is 10 cubic miles. Okay, that's an example of how to find the volume of a pyramid. Okay, now you will go through and find the volume of the other 6 on this page. There's other pyramids, there's some cones, there's some cylinders, there's no spheres, sorry about that, but that's some other practice finding volumes of solids. Okay, the last thing you're looking at has to do with density. Okay, and density is a measure of how much stuff there is. It's mass divided by volume. Okay, so we just talked about how to find volumes of stuff, and you take the mass and divide by the volume, and you have the density. Okay, you'll do these 3. I will warn you that this number here, number 2, is huge. because it's the mass of the pyramid, so it's a huge number. Just be aware of that as you find it. Many times students think they got it wrong, but really it's a gigantic number. Okay, the two I want to do, the most commonly missed, are the last two. I want to do those two in the video. Number 4 says, Tony Hawk, a professional skateboarder, is one of the greatest skateboarders ever. He was the National Skateboard Association World Champion for 12 consecutive years. It's pretty impressive. His net worth was estimated to be 140 million in 2018. In case you're curious. Okay, so you can build your own skateboard ramps by putting two, very common mistake, two of these wedges shown below back to back. I may say side to side, but they're going base to base. Okay, once two wedges are combined, it has a mass of 12.3 pounds. Okay, if you're a science buff, you might get mad at me the fact that pounds is kind of a weight, not a mass, and so I'm sorry about that. Anyway, just forgive me on that. What is the density of the total ramp? Okay. Now looking at this, you may say, well, it's a ramp, and you might think about the bottom rectangle as the base, and no, it's not the base. Okay. This is a triangular prism. Okay. You can't really think of it as a pyramid with a rectangular base. You can't think of it like a prism. Really, you have to think about. I'm not sure if you can see it, it's so dark, but this side triangle is actually the base of the prism, okay? Because you have the exact same triangle on this side. I don't know if you can see it very well. Let me try a different highlighter, a lighter highlighter. That helps, I don't know. But no, you can't really see it at all. But you have the same triangle there, and then it's connected by rectangles. Okay, does that kind of make sense? So this is a triangular prism, okay? And the volume of a triangular prism, or any kind of prism, is the area of the base times the height, okay? Or the base is one of these triangles, okay? Just like I did in previously, I like going off here to the side and finding the area of the base separately. Now this base is a triangle, so it's 1/2 the base of the triangle times the height of the triangle. Okay, just gotta keep the base and the heights clear. The base of the triangle, I'm gonna say, is 5. That's the base of the triangle, not the base of the prism. The base of the triangle is 5. 5 feet. And the height of the triangle, I'm going to say, is 1.5. Those are perpendicular, so that's fine. Is 1.5. Now, 1/2 times 5 times 1.5 is 3.75 square feet. Interestingly enough, it's very much like the one we did a little bit ago. Okay, so the area of the base is 3.75. Oh my gosh, almost exactly. That's interesting. Okay, sorry about that. Times the height of the prism, which is 4. Okay, and just like before, we get a volume of 15 cubic feet. Oh, this is feet cubed. Feet squared. This is feet cubed. Now, most students get there and then they get sidetracked and get excited about the density. There are 2 of these put together to get this mass weight. Sorry about that. Okay, so I'm going to take this volume and multiply it by 2. Okay, this 2 right here. And that's only in this problem, by the way. But it's a common misconception. So the total volume that I'm dealing with is 30 cubic feet. Okay, and I'm going to define mass. Whoops, not mass. My bad. The density. Let me change colors again. The density, which is mass divided by volume. The mass is 12.3 pounds. Just pretend that that's mass, not a weight. And I have 30 cubic feet. Oops. So I then divide them, and I have 0.41 pounds per cubic feet. That is what I'm looking for. Okay, that's the density of the total ramp. Okay, so basically you're finding a volume, taking the mass and dividing. Okay, the last one I will look at is this one. Patricia finds a heavy rock and wants to estimate the density of the rock. That's a normal thing that kids do these days. I'm just kidding. I don't know. Maybe she got bored being inside for so long. She first puts the rock on a scale and finds that it weighs approximately 490 grams. I know it's a weight, not a mass, but just anyway, that's the mass. The rock isn't shaped like a sphere or any other common object, so she finds a liquid measuring cup from her kitchen that has a radius of 3.5 centimeters, okay, and fills it to a height of 15 centimeters. I know. Anyway, she then puts the rock in the water and found that the height of the water is now 18 centimeters. Okay, we want to find the volume of the water before the rock is placed inside this right here. Okay, now we're assuming it's a cylinder. It says it's a cylinder. Anyway, it's a cylinder. Okay, so the volume of the cylinder, we look from our formula sheet, it's pi r squared, area of a circle, times the height. Okay, they told us that the radius is 3.5 centimeters squared and currently has a height of 15 centimeters. Okay, if you take pi, I'm not going to do this, I will do just find the overall answer, not in terms of pi. Pi times 3.5 squared times 15 gives me a volume of 577.27 centimeters cubed. Okay, now she puts the rock in the water raises. Okay, and now the volume of the rock and the water is, again, still a cylinder. It's pi r squared h. Okay, the radius is still 3.5 centimeters. The height is now 18 centimeters. And so my volume of the rock and the water is pi times 3.5 squared times 18. And I get 692.72 centimeters cubed. Okay. Now, the point of all this is that I can subtract these two and essentially subtract the volume of the water from the volume of the rock and the water and be left with the volume of the rock. So I can take 692.72 and subtract 577.27, and I get a volume of 115.45 cubic centimeters. That's the volume of the rock. Okay, and now the whole point of this, lesson is that density is mass divided by volume. The mass is 490 grams, and the volume I found to be 115.45 cubic centimeters. So if I whoops, you guys can't even see that. Sorry about that. So if you divide those, divide it by, then you get a density of 4.24 grams per cubic centimeter. Okay, so that is an introduction to finding volumes of prisms, pyramids, cylinders, cones, and spheres. And also talking about how to find the density of a solids when given dimensions and the mass. Thanks for watching.